Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. On today's show, we'll discuss the mean value theorem. Here's the concept. If you connect 2 points of a smooth function with a secant line, then there's a point between them where the tangent line to the curve has the same slope as the secant line does. If you're going along a smooth trip in one dimension, and there's going to be a certain instant at which you're traveling at your average velocity. That's really all that the mean value theorem means. Let's consider a simple case. It's called Rolle's theorem. If you start and end at the same point along a trip that's in one direction, so you're going forward from y equals 0 to y equals 1, and then back down to y equals 0, with the x-axis representing time over here, then you've gone forward, you've gone back. There's got to be an instant at which you're stationary, at which you're not moving forward or back. So there's an instant at which your speed is 0. Rolle's theorem can be stated as follows. If f is a continuous function on a closed interval ab and it's differentiable on the open interval ab, and if you end at the same place that you start, that is f of a is equal to f of b, then there's going to be a number c on the open interval a to b where the derivative is equal to 0. Let's consider the curve on the right. Well, here the derivative is never equal to 0. What's wrong? The problem is that the function is not differentiable along the domain. As a matter of fact, there's this one point, just a single point where the function is not differentiable, and that's enough to mess up our theorem. That we can see on this trip we've gone from 0 up to 2 and then back down to 0, but there's no instant where the slope is exactly equal to 0. But there is this one point where the slope doesn't exist. If the derivative existed at all points, then there would be a point at which the slope equals 0 if we start at one point and end at the same point. The mean value theorem is really just Rolle's theorem tilted. The statement of the theorem is that if f is continuous on AB and differentiable on the open interval from a to b, then there's a number c in the interval from a to b where the derivative of f at c is equal to the slope of the secant line f of b minus f of a over b minus a. Consider the curve to the right. We have a smooth curve, and we consider a secant line between 2 points, the green curve. It's a line between the 2 points. The mean value theorem says that there's a tangent line, at least one tangent line between 0 and 2, tangent to the curve between 0 and 2, with the same slope as the slope of this secant line. And here it's drawn, that we have a curve, or a tangent line with the same slope as the secant line has. Let's just work through that example. Our curve is y equals 1/2 x squared, and we're considering x equals 0 to be a and x equal 2 to be b. So we note the slope of the secant line is y of 2 minus y of 0 over 2 minus 0, which in this case is just 2 minus 0 over 2 minus 0, which is 1. We can also note that the derivative of y equals x squared over 2 is simply y prime of x is equal to x, and the slope of the tangent line will equal the slope of the secant line, the slope of the secant line being 1, when x is 1. So when x is 1, y is equal to 1/2, and the tangent line will have slope of 1 when x is equal to 1. Some related results that are based on the mean value theorem are the following. If the derivative of a function is always 0, the function must be a constant. Well, let's just take a look at that because it's really pretty simple, much simpler than it might sound. If the derivative of a function is always 0, well, f prime is always 0. But we also know that f prime somewhere between, say, a and x will equal to the slope of a secant line from x equal a to x equal x. That is, f of x minus f of a over x minus a is equal to f prime somewhere in the middle. But f prime is always 0. So we plug in 0 for f prime, multiply through by x minus a, giving us 0 is f of x minus f of a. And so f of x is equal to f of a no matter what x is. Therefore, if f prime of x is 0 on an interval then f of x is equal to the constant, in this case f of a. Similarly, if two functions have the same derivative everywhere, they can only differ by a constant. If we have f prime of x is equal to g prime of x, then consider f prime minus g prime. That's got to equal 0. So if we call that big F prime of x equals 0, then big F, which is just f minus g, is equal to a constant. Since f prime is 0, f is a constant, therefore f minus g is a constant, and f is equal to g plus a constant. A man goes out one night and drinks bourbon and water. The next day he has a terrible hangover. The next time he goes out drinking, he drinks scotch and water. The next day he has a terrible hangover. The third time he goes out drinking, he drinks vodka and water. The next day he again has a terrible hangover. He relates his problems to a statistician who promptly advises him that the cause of his problem is clear. He must stop drinking water. Thank you for joining us today. Have a great day, and may the power of math be with you.